All right, moving through Unit 10. In Day 2, we're talking about rational expressions. So today we're going to focus on simplifying rational expressions and finding what are called restrictions of rational expressions, okay? So first of all, a rational expression is an expression that has a polynomial in the numerator and or denominator, okay? So basically it's a fraction, all right? Fraction that has variables in it. So the problem is a rational expression can be undefined because in our case, when we're dealing with fractions, right, if we have something like 0 over 2, whatever, that's just 0, right? But if it's flipped and it's 2 over 0, we're not allowed to divide by 0, so that's undefined, okay? So there are occasions where these things are going to be undefined because we would have a 0 in the denominator, okay? We're not allowed to do that. So that's where our restrictions come in. So the values that would cause the denominator to be 0 are our restrictions, okay? So what we're going to do here is in the first few examples, we're just going to be finding restrictions, okay? So to find restrictions, all we're worried about is the denominator, the bottom. So restrictions, okay? What we're worried about here is the denominator only, okay? So we're going to say that the denominator cannot equal 0 to find those restrictions. So to state the restrictions here, we're going to take each factor in the denominator. So we're going to take this 5 minus x, and we're going to say that cannot equal 0. And then we're going to take this 7x plus 2 and say that cannot equal 0. Okay? And then we're going to solve these two things, and these are our two restrictions. So for this guy, we can just add this x over and say 5 cannot equal x, or x cannot equal 5, right? And then for this one, let's subtract 2. So 7x cannot equal negative 2 and divide by 7. So we get x cannot equal negative 2/7. So our restrictions, x cannot be negative 2/7 or 5 for that one. It can be any x value except those two, because those two would cause the denominator to be 0, be undefined, okay? So we do the same thing for all of these. We're worried about the denominator, but if it's not factored, we're going to have to factor it in order to find those restrictions, okay? So this one, to factor, this one is a difference of squares. Oops. So to factor, right, we've got two sets. One's plus, one's minus. Take a square root of each one, so we get y, and then plus 5 minus 5 is what this thing factors to, okay? So then we just take each factor again, cannot equal 0, and then solve them, right? So subtract 5, y cannot be negative 5, add 5, y cannot be 5. So our restrictions, y cannot be positive or negative 5, okay? And then same thing with number 3. So restrictions, again, only worried about the bottom. So the bottom, to factor that, we need to use big X. You're looking for what multiplies to negative 24, adds to negative 2, be negative 6 and positive 4. So that denominator, right, factors to this. So again, set each factor not equal to 0, add 6, subtract 4, right? So restrictions, x cannot equal negative 4 or positive 6, right? So when we find restrictions, we're just worried about the denominator, okay? So now to simplify these things, okay, like I got some steps up here, right? It says, first thing, it says factor everything you can in the numerator and denominator, right? So top and bottom, factor everything you can, okay? Find any restrictions after you factor by setting that denominator can equal 0, okay? And then we're just going to cancel out or divide out any common factors from the numerator and denominator after we find restrictions, all right? So in number 4, it says simplify each rational expression, state any restrictions. So first thing, it's already factored. So find your restrictions. So x plus 4 cannot equal 0. X minus 3 cannot equal 0. So subtract 4. And then add 3. So x cannot equal negative 4, positive 3 are our restrictions. Okay, these are part of our answer. And then to simplify this thing, all we're doing here is if we look in the top and the bottom, we have a common factor of x plus 4. So we can cancel that out. So our simplified version would just be x minus 1 over x minus 3. Okay? We cannot cancel out the x's, okay, because they're part of a subtraction, part of a difference, right? We got to be able to cancel out the whole factor, not just pieces of it, okay? So that's our answer there. For number 5, right, same thing. This one is factored for us. So for our restrictions, we just look at the bottom. So x plus 2 cannot equal 0. X minus 2 cannot equal 0, so subtract 2. Add 2. So x cannot equal positive or negative 2, plus or minus 2. And then if we look common factors here, we've got an x minus 2 we can get rid of, and an x plus 2 we can get rid of. So all we're left with is x over 1, or just x. Okay? Now, not always are these things going to be factored for us. So if they're not factored, we're going to have to factor them. All right? So in the numerator, there's a GCF here of 2. So let's take out that greatest common factor of 2. So if we take that out, we have 2 times x minus 1. And then in the denominator, 2x we can't do anything with, but this guy we can use big X for. Multiplies to negative 6, adds to 5, would be a positive 6 and a negative 1. So x plus 6, x minus 1. Okay? And then for restrictions, now we've got 3 things in the bottom. We've got 2x, x plus 6, x minus 1. So this thing's going to have 3 restrictions, sorry. 2x cannot equal 0, x plus 6 cannot equal 0, and x minus 1 cannot equal 0. So here, divide by 2. X cannot equal 0. Subtract your 6 and add your 1. So we've got 0, negative 6, positive 1, that x cannot be. Okay, there's our restrictions. And then now for simplifying this thing, right, we have a factor of x minus 1 we can get rid of. Okay, and then we got to think about here is multiplication between all of these things, right, that's separating these. So we can cancel out pieces of products, pieces of multiplication, but not when there's addition or subtraction with that piece, okay? So we can actually get rid of the 2's, and then on the top, we just have a 1 left because we canceled everything out. So we've got 1 over, we still have that x, and then plus 6 is what that would simplify to, all right? And then for this last one, number 7, okay, again, factoring stuff here. This guy, x squared minus 25, that's a difference of squares, right? So in the top, we have that x out front, one's plus, one's minus, and then square root of both of these, so x plus 5, x minus 5. And then in the denominator, there's a GCF here of x, so if we take that out, we'd have that, and then this thing, this trinomial on the bottom, we can factor with the big X, multiplies the negative 30 and adds to negative 1, would be negative 6 and positive 5. So now, numerator, and then denominator, we would have x minus 6, x plus 5. So for our restrictions, right, we got 3 things in the denominator we got to look at. So x cannot equal 0, x minus 6 cannot equal 0, and x plus 5 cannot equal 0. So 0, add your 6, and then subtract your 5. So 0, 6, negative 5 are our restrictions, all right? And then start canceling out common factors. So x plus 5 is gone, and then we can get rid of those x's right there. And so we've got left x minus 5 over x minus 6 for that, all right? So that's how we're gonna find restrictions and simplify rational expressions, all right? So try out that homework and let us know if you have any questions.